and welcome to another electrifying episode of the High Voltage Live Show. I'm your host, Willie Snyder with NEC Code, coming to you live from the Mile High City of Denver, Colorado. I am joined by my excellent partner in crime, Mr. King James Stallcup of the Volt Online Academy and creator of the High Voltage Live podcast. I was really stoked this week. We had so much awesome participation, and those numbers just keep growing in the NEC for Dummies. It really blew me away. I had like over 50% participation on my myth of the week just at NEC Dummies alone. So it's pretty awesome. I really appreciate all the people that's jumping in, participating, just helping out the electrical industry, kind of getting these myths out there and kind of getting people like, hey, why does the code say this? Or why does the code say that? Or does it really say that? Or, am I off base? So I post a list of the myths, which are kind of like created through thumb rules, kind of just some thumb rules that people say. And there's some good thumb rules and there's some bad thumb rules. But you get some of these myths out there, and that's what we're trying to do is go out there and bust the myths and just kind of make sure everyone's straightened out on the right page. And so that's why I did the Nat King code, just to post code questions every week and just kind of dig in a little in depth into the code. And James has like really helped out a lot, with the whole thing. And it meant a lot to me that you jumped in. And, like I say, this week we have a new segment coming this week, and I'm hoping to kind of keep it going and just kind of do some little fun things that are, not trying to just shove this code book down your throat and just kind of just tell you guys what it says and just have some fun with it. So hope you guys enjoy this episode, and appreciate you, James, for putting together kind of last minute. And I'm always seem like I get them to you too late, and apologize for that, but try to do the best I can to get them out early and get it set up. So once again, my hat goes off to you. Awesome job this week.
Well, whenever I get them, I still have stuff to do while I'm waiting anyway. So when I get it, I just take care of it and get it done real quick. So no big deal.
Yep. Awesome. Well, I don't know if you've seen this meme before. We were going to roll the meme right away. Yep. But this is one of the old school memes from back in the day.
All right.
Yeah, it's pretty funny on that meme too. What's funny about it is that's actually kind of changed a little bit throughout the years. It's actually a little bit different now. Like a lot of times these guys that come out there and do the troll post, they end up getting kind of messed up by all these guys that know what's going on. And, we have a few people, like there was one today that I thought was pretty funny where the guy says it's illegal to share neutrals in the code, and we've already covered that on one of our myths one week, so it's pretty fun and we're going to get those out there so that I can just go over there and share that line of that myth when we covered it, and then that way we kind of have it labeled and kind of have it more so people can kind of just say, okay, yeah, James showed that code language that week, or you know what I mean, like kind of like lay to rest a lot of these myths. And it was funny because one guy came on there and was like, oh yeah, that's an Edison circuit. And I don't even, it was weird because he's like, oh yeah, you can't have Edison circuits anymore. Well, guess what? The power coming in your house is an Edison circuit.
That's right.
So it was just funny that they're saying that that's illegal from code. And then we're sitting there telling them, well, you have this modular furniture. I believe that might have been my point that I made on that episode that we did, because we've actually done that before where it was spec'd out on the prints for us to pull individual neutrals, but the modular furniture has a whip that comes out with a shared neutral on it. Mm-hmm. So we still have to breaker tie it. We still have to handle tie it. Even if you pull dedicated neutrals, you still have to handle tie the breaker. Mm-hmm. And that was kind of what opened my eyes to it. Like, well, it doesn't matter, even if you still pull individual neutrals, you still have to handle tie the breaker. Like I say, that time I kind of caught it ahead of time, and they were like, well, let's just save the money on the neutrals and we'll just pull a shared neutral from the panel since we got a handle time anyway. And I just ended up putting on a 3-pole, but it's a lot of fun doing these every week. I have a blast talking to guys out at the job site and stuff, and just asking them what they think about different things. And so it's a lot of fun. And like this week, I don't even know what you put together for myth of the week, but it's kind of one that's a little bit controversial. There's a lot of times when we're out in gas and oil, and I know a lot of times with this whole COVID thing and everything going through, a lot of this equipment's got pushed back. And I know I saw one thing where it said Square D had a 54-week lead time on their gear. So it's really hard if you're kind of handcuffed on a job site and you have to get this gear built and you don't even have the pieces of the gear. So you have to like get the conduits in place, pull the wire, pull all your conductors and everything. And a lot of times it's hard. Like there was one in the comments where the guy actually had everything pulled, and then he had to like pull all the conductors out of the way so they could set the gear. And, I don't know if that's really worth it, when it comes down to the amount of trouble it's going to take to get all those conductors out of the way to set your gear. So it's interesting. This is one, and we've argued this one before with the pull point thing. And they actually had one at one point, the way the code language was, to where they said you have 3 bends with intermediate rigid conduit, and then you have 3 bends with RMC with just regular rigid conduit, and then you have like a GRC coupling. And nothing really said if that GRC coupling was technically a pull point or not. So basically says 360 degrees from pull point to pull point. And we were making that argument that there's probably some different kinds of fittings out there that could be considered a pull point if you did maybe a short section of raceway between them, which was permitted per this code. So it's interesting that I think there's a few things that we could kind of help out clean up, and that's how we come up with the myth of the week. So I don't know what you think. Did you like this week?
Yeah, no big deal. I just went and pulled a few things out of the code that I thought was important to look at, and I'll discuss it from that point. So,
all right,
let's roll.
Myth of the week.
It's time for Myth of the Week.
All right, so awesome. So this was a really funny one that we run into every now and then. And this picture, this isn't just necessarily a picture of a violation. If you were to go ahead and sleeve some seal tight on this and run, say, in the back of that enclosure, there's really nothing that says you can't do that. Short sections of raceway are permitted to do this. In all actuality, I have ran into, you basically, a lot of times what the inspectors want you to do is they want you to complete the raceway, both ends. They want to inspect it for rough inspection, and then you pull your conductors, make it up, then they come back and check it for a final inspection. So usually the inspectors want this as a 2-part installation rather than this. And there was a lot of awesome comments that I saw that I really enjoyed this week, where they were like, oh, well, where's the inspector? How's the inspector going to find out, and different kinds of things where it's like, yeah, nobody's really going to know. And I think that they just did this for almost in the code as like a continuity thing to kind of just make sure that you're kind of doing things in a step-by-step order. There was one that I saw, one of the Facebook groups that I saw, where they had pulled their conductors. they were getting ready to set the panel, but they had to let them pour the slab first. So they had all their conductors coiled up and everything. Well, they went and poured the slab. They had it all coiled up, sitting up on top of the thing. Well, then they left. Everyone left, and the coil of cable or the coil of conductors went and fell down and fell in the concrete, in the wet concrete, and actually basically by the time they came back in the morning was dried into concrete in the morning. So that's the kind of thing where I kind of get this from, and they were trying to get a liability of who was going to pay for it, and they ended up finding out that it was a code violation. They should have actually mounted the panel and then pulled the conductors into that panel. Then they wouldn't have fell into the concrete and been buried in the concrete. So, right. That's kind of the real world where I see it from this standpoint.
All right. Well, I'm going to show you a couple of sections here where I agree with what this says. When you go, since you based it on 2020, I went to 2020 NEC, and the first thing I looked at was 300.10, where it talks about the electrical continuity of the metal raceways and enclosures, and it basically just tells you that they have to be metallically joined together in a continuous electrical conductor. Now that's funny because the way they're sort of reading that, they're talking about the metal raceways, cable armor, or other metal closures for conductors, and then it says joined together in a continuous electrical conductor. So to me, that's telling me everything has to be, the raceway system has to be complete. And as you said, you had exception 1 there that talked about the short sections of raceway. That's an exception to that rule. And then there's another one where the equipment is isolated, and it'll tell you 250.96B. And basically what that is where they go in and put a non-metallic spacer between it for electromagnetic interference. And then when you go and look at it, 300.11A tells you all your raceways, your cable assembly, boxes, cabinets, fittings, they have to be securely fastened in place also. And that goes back to what you were talking about, where the conductors fell out into that concrete. Now, I also went and looked at 300.12, and it's the same thing when you're looking at mechanical continuity for the raceways and cables. And it says it has to be continuous between the cabinets, boxes, fittings, or other enclosures. And looky there, they have another one, exception 1, mentioned in them short sections of raceway again. See that? And then 300.13A goes the same thing and talks about conductors and raceways shall be what? Continuous between all of them. So that's tying all that in just one section after another. And then if you go look at 300.18A, that sort of finishes it up, and you got the exception there again for the short sections of raceway. It basically just tells you it has to be a complete run. Now, I did think about this a little bit, where sometimes there's a leeway depending on the type of job and everything that's being done. And I wanted people to look at here, looking at 90.4, and I wanted to mainly look at the second paragraph, and it says, by special permission, the authority having jurisdiction may waive specific requirements in the code or permit alternate methods where it is assured that equivalent objectives can be achieved by establishing and maintaining effective safety. So I look at that, and I look at that as far as safety, because you're also looking at that where you're not going to damage the conductors, because that will, if you damage those conductors, all of a sudden you're not providing effective safety at that point, because those conductors, if you didn't see them getting pinched or something like that, or you had something that dug in the installation, now you've got a problem there. So they can take and waive specific requirements or permit an alternative method, but there needs to be a reason before you do that. Otherwise, I sort of feel that everything has to be maintained as a complete raceway system, everything mechanically secured, and it's all that includes the raceway and the conductors.
Yeah, and that's a really good point, because there was a lot of comments of people mentioning like, hey, how's the inspector going to know about it? Well, a lot of people don't realize that a lot of these inspectors went through the trade the same way we did. And I'm not saying a lot, but like actually here in Colorado, it's actually a requirement to be an electrical inspector in the state of Colorado. You have to go through a 4-year apprenticeship. You have to pass the Colorado Journeyman's exam. And that's the only path you can go to be an inspector here in Colorado. So to me, I like that. I think that's good because then I can have a courtesy call, have the inspector come in and say, you know what, this is what I have. I have a 54-week lead time on my gear. The customer wants this job done in 42 weeks. What are my options here that we can go ahead and move forward and try to get some of this stuff done? Maybe some alternate methods that, you know, maybe a lot of people wouldn't have thought like outside the box and thought, well, maybe, yeah, you could do that or you could do this or whatnot. You know, you could build this whole section of gear, maybe cap it off to a junction box and then get your main gear fired up and, you know what I mean, just isolate that section. And there's different things you can do. And we've had to work through some of these challenges, like working in the gas and oil industry. There's a lot of weird stuff that we have to do that's not normal towards the industry. We've had times before where they're like, all right, there's a top secret building that's getting delivered. We can't tell you what it is. It's some secret process. And they come have this building on a skid, basically come delivered from wherever, probably Texas or somewhere, you know. And actually there was one I thought was really funny. One of the buildings was built in my hometown, Arvada, Colorado. But it was pretty funny. I was like, wow, this whole thing's built and assembled Arvada, Colorado, right down the street from my house, you know. But and it's coming out to like the Wyoming border, you know what I mean? I'm like, okay. But we have to have these things built, like we have to have all our wiring just sitting there waiting for these buildings. And then they show up with these buildings, drop them, and then we got to wire them. And if we're sitting there waiting to build raceways and to like tie into the building and to, you know, pull conductors, like a lot of times we're doing like tray cable, because that was one of the comments I really enjoyed that was in there too. Somebody's like, yeah, it's got to be complete even if it's cable tray. You know, well, how do you complete cable tray when the building's not even there yet? You can't even complete the waterfall into the building. You can't even do anything. You know, you can't even drill out your stovepipes. You can't do any of that stuff till that building shows up. So a lot of times we try to be as prepared as possible. We know the requirements of what's going to be required for certain things. We know it's going to have, you know, a 4160 volt section. It's going to have a 13.8 section. We know we need, you know, 9 parallel runs to the 13.8 section. We know that, you know, we're going to have a 4160 step down transformer to 480. So we can get those pads set for the transformers. We can get our pipes from the transformers into where the gear is going to go inside the building. You know, we can get all that stuff stubbed up into our windows and, you know, basically get as much done as possible. So when that building shows up, they drop that sucker and we just start drilling it. We just start Swiss cheesing that building, you know, and start, you know, a lot of times we'll have our conductors just sitting there. We'll have our tray cables already pulled. I mean, some of those poles are like half a mile, you know, and you're coming on 3-story tall tray, you know, from the gate all the way to the, you know, EEC building to your control building. So you have to have all that pulled. Like, and are you telling me that you're going to sit there and wait for that building to get built before you start pulling tray cable? I mean, you'll just get destroyed. So a lot of that stuff we have to take with a grain of salt. And out in the gas and oil, usually the head engineer on site is the AHJ basically. So he's basically granting us special permission to do whatever we want under his supervision, under engineering supervision. So, you know, like I say, a lot of that stuff it's put into perspective by me. That's kind of why I like doing these myth of the weeks, kind of, because a lot of people just only think through the glasses of the residential guy, or only look at through the glasses of the commercial guy, or whatever. There's some people out there that watch this show that aren't even electricians, and so we try to bring that whole common thing together to where they all kind of understand, like, hey, you just got to do what you got to do, you know.
Sure.
So,
It's no different. I mean, how many times you see that they have whips that are up above the ceiling waiting to install light fixtures, or maybe you got a whip out there for an AC unit or something. I mean, there are things that you work with authority having jurisdiction. They understand that it's not going to be damaged, and it's fine. And like an installation you were just talking about, engineering's out there. They know what's going on. They want to get set up for it. It's an alternate method that they're allowing because they need to get prepped for it. I mean, and that's why I brought up 90.4, because there are things you look at that you don't have to be complete all the way through. But I believe if you're going, you got cabinets there and everything, you need to complete the raceway system. So
yeah, and it's gonna help you in the long run. And I think that was a really good point that you made with 90.4, because what I've found in the past is you're way better off having the inspector on your side than trying to fight the inspector. I've seen times where guys are like, I'm going to fight the inspector on this one. I'm like, why? You know, the inspector's just trying to do his job. And I've had times before where inspectors are like, they're telling me, oh, this inspector, he always wants a bunch of weird stuff. And I'm like, okay, well, I'm going to have him show me in the code where it's at. And, you know, one of them was this Denver inspector, and he always wanted a ceiling wire going to the can light. And I was just like, you know, the thing that I always found weird was there's no little place for the ceiling wire to go on a can light. Mm-hmm. So we're kind of not really doing it right, because we're just tying this ceiling wire off to the arm of the, you know, can, because that's the only place you can put a ceiling wire at or whatever. It's not really doing anything. But I just said, you know what? I said, why don't these recessed can manufacturers make a place where you could put the ceiling wire if they really want a ceiling wire going to them? He says, yeah, you know, that's a really good point. And he says, well, you know, what would you look up if you wanted to, you know, do this? We've already covered this myth too. But I was like, well, go look in 41036B, and it says it just has to be attached to the ceiling grid. It doesn't say anything about a ceiling wire needing to be there. He says, you know what? He's like, you're the first person that's really challenged me on it and got me to think about it. And he's like, don't even worry about it, you know. And so it meant a lot to me that, you know, when you're just asking questions, you're not being confrontational. You're not calling them out or being mean or anything. You're just like, hey, just show me where it is in the code. Just show me where it says that that's even a good idea, you know, because literally that's just a wire sitting there doing nothing on a recessed fixture. But,
right,
you know, like I say, if that was defined as a junction box in 314, then it need a ceiling, you know, it need to comply with 311. So it is what it is. It all fits together, and we're just trying to piece it all together for you guys. But I really appreciate James. That was freaking awesome putting those slides together. And really made sense. Everything just fits together. So
yeah,
myth is confirmed. It needs to be a complete raceway for you pull conductors.
Yeah. That's why I said there's a lot of sections there. You just read them, go right down in order. Mainly everything's in Article 300, and then just tie 90.4. Hell, you're good to go.
Yeah.
So, all right, ready for the topic?
Yeah, let's do it.
All right. All right. Well, the topic this week, I was thinking about this, and we had made mention of this. It's been quite a few weeks back, and we were talking about somebody had asked a question about motor circuits and stuff, and I said I'll do a topic on that. So I'm going to do the motor branch circuit and feeder conductors, how to go about sizing them. It's very simple, but the last portion of the slides that I'm going to have, they're from the 2017 because they're updating all the illustrations that are in the motor section. But this is going to go in showing part winding motors and where you have periodic duty, intermediate duty, and all of that. You're using the duty cycles and all that. So I'm going to show quite a few different type of calculations here that people might have never seen. So I decided to go through this and just sort of show everybody, and they're pretty basic. And the first one you're going to look at here is we're going to be looking at 430.22, and we're just going to be looking at doing single motors. And when you look at this, it tells you anytime you're doing a single motor, and it doesn't matter if it's for single phase or three phase, we're going to take it at what? 125%. Okay.
Yes, sir.
So here's your table for sizing the conductors. I actually have two of them to show two different types because I have it in two parts here. This is part one of table 310.16 that goes up to 4/0, and we're going to be using the 75° C column when we do this. And then anything, if it was above 4/0, here's your 250 up to 2000 KC mil. All right.
So the reason behind the 125% is that most motors are considered to run for more than 3 hours at full load.
Right.
Gotcha.
And when you look at this, I didn't even do the calculation here. I'll show some of them in the others, but I just wanted everybody to sort of get a look at what you're looking at when you go in and you start looking at sizing these conductors. So if you look at it and you see the panel board there, and then I'm going to the disconnect, and right there we show you the conductors, and it says 430.22. Now, I could take that disconnect. It means we're showing you that as time delay fuses. Now, we know just a little while back, we touched base on this a few weeks back. Ryan come in and said that was a feeder. I'm telling you that's not a feeder. Okay. That's where you're sizing your branch circuit conductors over to it. All right.
Yeah, I mean, in that case, like, where is your final overcurrent device? I mean, that's kind of a weird way to look at it, I think, as far as interpretation goes, you know.
Well, sure it is, because you're feeding a single motor. A feeder is two or more motors or a motor and other loads. And we'll look at that when we get to 430.24.
Would that even get more complicated when you get into like the definition of like appliance with the combination of motor and other?
Well, the only difference is you're going to use a nameplate value. You're not going to use the table value.
Oh, got you. Okay. Tempor, got you.
Yeah, and when you look at this, we put an exercise problem here for you to look at. And I'm not going to go through this because everybody knows how to size, a single motor or two or more motors. And all you would do is we're looking at this, and we have a 2 horsepower motor. It's single phase, 208 volts. All you're going to do, and I like to break this down so everybody knows where they're looking at. So when they're going through, listening to me teach this, I want them to actually go back and look and try to work this problem on their own. Right. So if you go and look at 240.4G, okay, when you go pick that heading up there, it says specific conductor applications. And then you go down and it's going to talk about motor control circuit conductors. And it's going to it'll say, see Article 430, and it's going to have all of these parts. Okay.
Right.
Well, then I also teach it this way. I say, whenever you get ready to start doing your calculation, go look at 430.6A1 at the very front of Article 430, because right there, it's going to talk about the heading, and A1 is going to talk about table values. And basically what it says is anytime you're calculating your conductors or overcurrent protection devices, you want to use the values that are given in tables 430.247 through 250. In this case, since we're doing a single phase, I'm going to look at table 430.248 to go get the amperage rating for that horsepower. So that would go in step 1. So I just
Right.
took the 208 volt column, come over to horsepower. I'm not going to tell the value. I'm going to let people do this one. And then you go down to step 2, and 430.22 said to take it at what? 125%.
Yeah.
Once you calculate that, there's your amperage. Then you go to table 310.16, and that's where you're going to go to the next size above that calculated amperage in the 75 degree C column, and it's going to tell you the size conductor. Okay?
Right.
Now,
well, and one thing I was going to say too, for all the people out there that doesn't know James and his material, if you're getting ready for like a journeyman exam or something, there's no anything better out there than this kind of content. I ran through James's stuff before, and it just gives you that confidence that you know what the right answer is. You're not missing a step. You're not missing a code loop. You're not missing anything in there. He makes sure and covers everything that you need to know to get the correct answer. So I really appreciated that about it.
Well, I appreciate you saying that. And, you know, the way those calculations have been designed has been through, 30 plus years, 40 years of teaching, and the students asking certain questions. We may even add another step sometimes to make it even easier to understand. And that just comes from the people out there asking us certain questions. Now, this one is a 3-phase. Now, I want you to look. It's the same calculation. The only difference here is I'm using table 430.250 for 40 horsepower, 3-phase, 460 volt design B. So, and I'll just help just a little here. If I pick the 460 volts up, come over with 40 amps, it's going to tell you it's good at 52 amps. Okay.
Right.
That's how you can get it. Then I come down to step 2, and what do I take it at? 125%. I did not change the calculation. Once you get that amperage, then you go to table 310.16, and the next size above that amperage is going to be your size conductor. Okay.
Right.
So instead of me doing everything for everybody for once, I want everybody to sort of have a little bit of go look this up and see what I'm telling you. And you can look right here, and you can see the sections that are in the table or in the illustration that we want you to look at. So 430.22 is my 125%. I size my conductors. Table 310.16. It's all there. Okay. Now, one of the other cool things about this is when you're going through, it doesn't matter if it's through the publication or it's through the online course. Before you get to this illustration, you see those steps right there in the exercise problem. There's going to be an example problem before that actually has the sections, tables, and everything in each one of the steps. The reason they're not in this, because we want you to get used to learning where to find that information when you get to this point. And what's really cool about this, once we get this ready, is you're actually going to be able to go online, and like where that 40 horsepower is, all you do is go online, you click that blank right there, and you can fill in the value. So if you're out on the job, you can do it. You can put your own values in to remember the step procedure you're going to use. You can also click those sections over there. It'll pull up the section so you can see exactly how we did that calculation and where we got those percentages from. So in a way, this is very helpful for the people out in the industry, just not prepping for a test, just an everyday on the job tool.
Yeah. So, and I agree with that. There was this was kind of a funny story. We were arguing some stuff out on the job site, and I knew that I was right because I've done it for a while, and I just passed the fire alarm test. And I'll tell you, nothing's better than studying hard and actually knowing the right answer on a test. But just like James was saying, we go out on the job and everyone's like, no, you're wrong, and they're just pie in the sky arguing about some stuff. And I said, well, it's like this because of this. I don't really understand it as good as I probably should. But the way I understand it, we should be setting these devices like this. Well, next thing you know, they call all these different people out and all these different experts and everything. Next thing you know, I hear them all, "Oh, we got to go back and fix them all," because I was right. But it was just funny, and I enjoyed, just being right for once. But at the same time, it's like I don't care about really being right. I want everyone to have. I want everyone to excel in the industry.
Mm-hmm.
That's my goal. And I know you have the same goal yourself.
Oh yeah, and that's why we spend so much time simplifying things the best we can. And like when you look at this right here, here's 430.24, and this goes back to what I was talking about the feeder a while ago. I said if you're going to a single motor, it's a branch circuit. There's no feeder. I don't care how that definition he tries to twist it the way he wants. This is fact here. And what it says here, several motors on a motor and other loads. And it says here, conductor supplying several motors or a motor or motors and other loads. Okay. Right. So that's telling me there's two or more here. All right.
I agree. I agree 100% with that.
And it's not going to a single. Now, when you look at this, it says, and if you look, it says go look at 430.66A, which is what I was talking about, the table values. And it says the largest rated motor that's there, you take it 125%. And then in Prin 2, it says all the rest of them are added at 100%. But I'm still going to use the table values to do this calculation. And that's why I said start at the front, and it's going to come back and tell you what you're doing is correct. All right.
Yeah. And then I do like that interpretation on that, just for the fact, kind of like we go into the definition of individual branch circuit, because individual branch circuit doesn't connect to an outlet.
No, it doesn't.
Why would they need to have a specific definition that does not mention an outlet?
Sure.
So I'm going to be interested this next cycle because they're trying to go get outlet added to individual branch circuit, and I think that's going to be a tough sell.
It's going to be a tough sell for the simple reason is you can have a branch circuit that just supplies an outlet. Just in the definition of branch circuit, it says outlet or outlets. So why do you have to have a definition for an individual branch circuit to utilization equipment if you already have it there for a branch circuit?
Right.
I mean, that makes no sense. But
yeah, go ahead. Sorry to interrupt.
And then if you look, it says in Prin 3, if you have non-continuous non-motor loads, you take it 100%. And if they're continuous non-motor loads, you take them at 125%. And then there's another one I'll point out as exception 1, because we're going to look at it in a little bit, where I talked about where you had short time, intermittent, periodic, varying type duty motors. It's going to refer you back to 430.22E when you're doing that calculation. Okay.
Right.
And I'm going to show you that calculation. It's actually pretty good. All right.
Okay.
Now, if you look here, you'll see in our illustration, we tell you feeder conductors. You're going over to that gutter, and we tell you to look at 430.24 and also 25, and then you feed everything from that point. And if you look, I want everybody to see this. This calculation hasn't changed. I'm going to go look. This is 3-phase. So I'm going to look at table 430.250. And as I said, you just go over here and you pick up your 40, 50, 60 horsepower and put the amperages there. And then whichever's the largest, which is the 60 horsepower, you take at 125%. And then everything else is added at 100%. And whatever that amperage is, go to table 310.16 and go up to the next size conductor in the 75-degree C column. And that's
so basically what you're saying is that potentially, so you have your feeder coming from your let's just say that's an MCC, whatever, coming from your source.
Right.
Then you have your feeder. Then would everything after that disconnecting means be branch circuit, or would they all still be feeders?
No, those are branch circuits connecting to the feeder conductor.
Gotcha. So that would be like a tap gutter connecting the branch circuits to the feeder, or actually it would be feeder on the line side of that disconnect, right?
Sure, because you're coming over,
Okay.
you're taking your feeder, then you got each one of those calculated separately. Alls we're doing is having a size feeder over there for all three motors that can be running at the same time, with the largest
Gotcha.
taking at 125%.
Oh, okay, I see. So they don't all have to be continuous duty. They could all be different duty cycles, and you're calculating that feeder based on the 125% and 100% and all that. I got
Right.
you.
Yeah.
Okay. So it even
And
goes even down to calculation too.
sure. And alls we're doing at this point, I've already showed you how to do the branch circuit going down there. Alls we're doing is making sure the feeder's large enough for all three motors. And that's what I'm
Gotcha.
saying. That's what a feeder is. It supplies two or more.
I
Okay.
see.
And then
Okay. Yeah,
everything
makes
down
sense.
from that point is a branch circuit,
I got you.
which
Okay.
which would be
Yeah.
funny because uh, uh, if I come from up there from, I say that's a feeder, and I come down to that disconnecting means right there, that is going to be a branch circuit from that point. You see what I'm saying? It's not
Mm-hmm.
going to be a feeder to a branch circuit. That makes no sense.
Yeah.
How you're going to size two feeder conductors at that point is what Ryan was
Right.
saying. That you don't do
Yeah.
that.
Well, and then your tap rules too would kind of dictate some of that sizing. So, like, let's just say you went and added a fourth disconnect, and then you went with like the 10-foot tap rule, then you'd have to go off that whatever that is feeding that uh, MCC or your panel board, and just make sure that you're following those tap rules and going 10% of that primary overcurrent device if you're 10 foot, or 1/3 if you're 25 foot.
That's right. And when you go over and look at that, and you look at your tap rules and everything, and tie that in with 430.28, that's where those tap rules come in. And basically, once you size that feeder and that upstream overcurrent device 10 foot or less, that's going to be divided by 10. If it's over 10 foot, everything else is taken at a third.
Gotcha. Yep.
Okay.
I would agree.
All right. Now, this is one I'm going to look at dealing with my my phase conversion here. And this is where you get into A1, A2, depending on if it's a variable load or a fixed load. But we're going to look at doing a calculation on this. And I'm not going to do anything different here. I'm just going to show everybody here. We're doing, in this case, we're going to do a variable load. All right. Now, all I'm going to do is I'm looking at this. I got a three-phase motor. I'm going to go look at table 430.250, pick up my 230 volts, come down for 25 horsepower, get my amperage. And then if I go back here and I look at this variable load, it says to take it at what? 125%. So I'll take it at 125%. And then whatever that amperage is, I'll go look at table 310.16. The next size above that amperage rating is the size THWN conductors you need. Now, the thing I like to point out, did you really see any changes in the calculation other than the remaining motors being taken at 100%?
Yeah, no, it's just largest motor, right?
Mm-hmm. It was the same calculation. Everything was at 125% so far, except what? The remaining motors at 100%.
Oh, yeah.
That's it.
And we run into this too, just to give all the people watching this context. We argue this nameplate argument a lot. And, people are like, oh, you're putting number 14 on a 30 amp overcurrent device, you're going to burn places down. Well, what you don't realize is that if you do all this calculation correct, that motor is only going to be running about 15 amps.
Mm-hmm.
Just because it's on a 30 amp overcurrent device doesn't mean anything. So
it's just there for the starting current startup of the motor, because you have that inrush current. That's it.
Yeah, and you mentioned that 240.4G, which gives you special permission to add overcurrent, exceed the overcurrent of the conductor. So a lot of people mention the asterisks in 240.4D, and that would be incorrect and incorrect interpretation. The reason why they give you this special permission is that nameplate that's on that motor is going to give you the minimum circuit ampacity, and that's all you have to cover. And that motor is actually the only thing you're supposed to provide from that panel board or MCC. I don't know. I'm not trying to say your illustration's wrong, James. I'm just saying it's more visual for me from like an MCC standpoint. But when you're coming from that panel board, that source is only required to provide short circuit and ground fault protection. That source is not required to provide overload protection.
No, and the reason it's set up like a pound board is because we only have so much space on the.
Yeah, and that it's fine. There's nothing wrong with it. I was just kind of for a lot of like I have a lot of industrial people that follow us and always ask me, well, is that a paddle board or MCC? But it doesn't matter either way. It's your source. It's right. People don't understand that you don't need that 30 amp overcurrent device is not required to provide overload protection for the thermally protected motor.
Right. Now, this is good because here's one we're going to look at 43022B, and I'm going to start tying in a few extra ones that people usually don't see these type of calculations. But this is for a multi-speed motor. And basically, it just tells you the same thing here. The ampacity of the branch circuit conductors between the controller and the motor shall not be less than 125% of the current rating of the windings that the conductors energize. Now, the reason I'm bringing that up is because those are the conductors between the controller and motor. But now, if I'm looking at the selection of the branch circuit conductors on the line side of that controller, looky here. It says it shall be based on the highest of the full load current rating shown on what? The motor nameplate, which is what you were just talking about. So if I'm doing multi-speed motors here, they're not using 430 points or using the tables. They're using the nameplate because they're telling you to use it.
Right.
Okay. So when I look at this calculation, and this is one that's getting updated right now, but you'll see we're showing you here, we have these multi-speed motors and we're showing you the RPMs for the motors, and then we're showing you what the amps is for it. Okay. Well, naturally, we got at 3420 RPMs is 27 amps, 2280 is 35 amps, and 1710 is 45 amps. And it says when I'm doing the branch circuit conductors, I want to take one of the largest at what? 125%.
Yeah.
So you take 125% of that 45 amps, that's 56.25. The next size above that, and you can see it says table 310.50. It's table 310.16 now. That would be 65 amps, which is the number 6 conductor. So that's the branch circuits coming over to the controller. Then when I get to the multi-speed controller, it said to take each one of those at what? 125%. So I'm going to size each one of those multi-speed motors individually. So you take 27 amps at 125%, 33.75 amps. 35 amps at 125% is 43.75 amps. And 45 amps at 125%, like it was for the branch circuit conductors, is 56.25 amps. Then you go down and look at table 310.16. And it tells you need a number 10, a number 8, and a number 6.
Wow.
That's simple.
Okay. Yeah.
But if you notice, the only difference that changed in this calculation is I still did the largest motor. I just didn't add them at 100% because they're going to operate at different times. And then once I was going to operate each individual one, then from that controller to that multi-speed motor, then you're going to do each one of those conductors individually. But I still did it at 125%.
Yeah, and actually, this is actually not bad because Mark Candles will be happy because you got the 310, 15, B16 in there, and he's still on 17. So
Well, I can tell you those are being updated, and all the colors, panel boards like you were seeing in the previous ones, that these are what they're going to look like.
Nice.
All right.
Well, I really enjoy it, and one little tidbit, I will be doing a lot more stuff on 2023 moving forward. Like once Colorado adopts 2023, I will be doing a lot of my stuff based on 2023. I haven't switched to 2023 yet, just because we're still on 2020. So
okay. Well, now here's another one you don't see much of, is where you get into a Y start delta run motor, and it tells you when I'm on the line side of that controller, I still take everything at 125%, but it tells you for 430.6A1, so that means I'm going to use the table value here. Okay. And then it says then passage of the conductors between the controller motor shall not be less than 72% of the motor full load current rating. And where's that multiplier attained from? That's multiplied in the informational. It shows you is multiplying 58% by 1.25 or 125%. And that's 72%, but it's still you're still in the calculation going to use the 58% because I'm going to use the 125%, which makes it 72%.
Yeah, I remember that. That was one of our controversial ones in the death match we ran into.
Yeah. So looky here. I'm gonna show this. This is very simple. So I'm looking at that motor, and we're telling you here it's a 3-phase motor. We're just giving you all the information here. We're telling you it's 52 amps. Okay. So if I'm doing the branch circuit, I take it at what? 125%. Yep. Done. Doesn't get much easier than that. Then we tell you here, we say, all right, now if you're doing between the conductors between the controller and motor, you're going to take that 52 amps, but I'm going to take it at 58% times 125%, and that's going to give you 37.7 amps. And then you just go to step 2. Based on those amperages, there's your size conductors. And that's what I'm saying. If you notice, I still had the 125%, but since this was a Y start and a delta run motor, I had to take it at 58%. And that 58% times the 125% is where you got the 72%.
Gotcha. Okay. So would it work both ways if you did it both ways? Like if you went and you just, instead of taking it at 58%, just took it at 72%.
Yeah.
Because it's already calculated in.
Yeah, you get the same thing. Yeah.
All right. Yeah, that makes sense. So either way, it's like apples, oranges, whatever, and tomato.
This is an easy one. Part winding motors on the line side of that controller, I still take it at what? 125%, and it tells me to use 430.6A1, which is going to be the table values. And then it says between the controller and motor, it shall not be less than 62.5. Well, since it's part winding, that means half. So I'd take the 125% times 50%, and that's where you get the 62.5.
Gotcha.
Okay. So here's the same calculation. I'm going to come in here. I look at table 432.50, and it tells me that 40 horsepower, 230 volt 3-phase, I need 104 amps. Take the branch circuit conductors at 125%, and that's going to give you what? A number 1, which is good for 130 amps. Now, if I'm going to do from the controllers to the motor, guess what? It would be half of that.
Right.
That's how simple it really is to do. So it would just be 65 amps, which would be a number 6 conductor.
Yes, sir.
Okay. Now,
you're going off the 75 degree.
Yeah,
cable.
75. Yeah.
Dude, so there is some controversy on that. Just to shout out to everyone who always brings this up. if you're like in a testing situation and the terminals are unknown, then you have to go off of 110, 14,
C1A and B.
C1 A and B, and go off the 60-degree column. I doubt you're like, there's people showing me terminals from the 60s that were 75 degree C rated. So I doubt you're going to find any that are not 75.
It'll be a much older motor if you're going to run into a 60.
Yes, sir. I agree. I just wanted to throw that out there for guys that just so they understand, don't get confused.
All right. Now, this one is other than continuous duty, and this is where you have short time, intermediate, periodic, and varying duty type motors. And it tells you to have an ampacity not less than the percentages. And this is based on what? The nameplate current. Okay. Yep. So I'm going to use the nameplate current, and then it tells me to use the percentages that are in table 430.22E. So if I look at this table, depending on what the rating of the motor is, let's just say that I had a periodic motor that was 15-minute rated. You're at 90%. If it was a 5 rated motor and is, say, intermittent, then it's 85%. Okay, so this is where you're going to pick up the different type of percentages based on the type of motor. So when I look at this motor, and I've got a 100 horsepower intermediate 15-minute duty. So and I'm just going to go back and look at the table. It's 15-minute rated and it's intermittent. So here's 15, come down, pick up intermittent, tells you it's good at what? 85%. Okay. So if I come over here and I take a 100 horsepower motor, that's 460 volt 3-phase rated at 124 amps. You go to table 430.22E, take that at 85%. That's going to give you 105.4 amps. And the next size above that's 115 amps, which is a number 2 conductor. And that's how you size for duty cycle type motors.
All right. And so we had a question come in, really weird question came in. What's a motor?
Yeah. I wonder where that came from.
That was so funny. That was on NEC Live.
I got to talking too fast.
So funny. Dude, that's awesome, man. I love your content, sir. It's really awesome, and just like you just keep bringing the heat, you just keep elevating every time. I really appreciate you putting the illustrations in, even the ones that are not updated yet, but everyone could see the difference. I think you could see the contrast. Like even your 2017 ones are even still good.
Yeah, the new ones are really going to blow it away. And I'll say this: you can go look at a lot of these other publications. Some of that stuff I was showing you ain't gonna see that in other publications, and they don't go that in depth. And I'll tell you this: when you go into our generator transform motor compressor book, we go very in depth on all those calculations. And I always try to teach it from the easiest standpoint possible. And what I like to point out about all them calculations, pretty much everything was at 125%. And the only time you really worried about it was where you got that Y-Start Delta connected top motor. You had the 58% and a part winding motors at 50%. And then when you got to varying duty, you just need to look at table 430.22E for the different percentages. Other than that, everything was 125%. So it shouldn't be that hard to understand it.
Yeah, and you saw the one that I did for the minimum, because I got a lot of people fired up because the minimum is 115%.
That's for the disconnecting means.
Right. But yeah, like I say, it was interesting because, like I say, that was one part that isn't 125%. It caught people off guard,
Sure it does. And that's just needing to know your different sections. We actually show you that calculation and looking at 430.110A to apply that 115%. And we go through all that. And basically all it's telling you, is that's the minimum for that, but your size in the conductor is 125%, so it's going to be large enough anyway. But
Right.
the thing is to show you in the code the percentages. So if you were taking a test and they ask you how to calculate for that disconnecting, means it's 115% is the minimum.
Right. And I really give a big shout out to all the people that answer the code question of the week. It's been a lot of fun for me. So feel free to smash the like, subscribe to our channel, follow us on social media. James is on LinkedIn. His dad's over there on YouTube doing, Pop's put out probably 3 videos already on different stuff for the code changes. So he's been busy too. But so you can always look at Hot Topics and the James Gray Stall Cup YouTube channel, and he's out there doing it.
Looks like we're going to be contracted out to do a safety manual for a very, very large company, and if we get it, I'm going to tell everybody about it. It's a mega billion-dollar company that's wanting us to look at and putting our safety manual together like we did for editing and doing everything for the Department of Energy and Defense. And I think it probably came from this YouTube channel. They're like, y'all did that? And like, yeah. And ever since we started doing this YouTube channel, picking up a lot of
golf clap
stuff like that. So, and people don't realize all the things that Dad and I have done through the years, and major companies we work for. I mean, we used to do stuff and be expert for OSHA, in cases and stuff, still do sometimes. And they don't call anybody, that doesn't know what they're doing. Let me put it that way. And
right.
It just sort of shows, a lot of people believe in our knowledge on the codes and standards. And I believe our publications have a lot to do with that too. So.
Yeah, and it means a lot. Like, I kind of started the Nat King Code page as a joke, just to joke around and have fun. And it's kind of gotten a lot more serious. And I've actually had a lot of students out there that are very happy with the content that I'm providing. And basically, I'm doing it from a real world standpoint, just based is this a code violation or not?
I told you to get serious, didn't I?
Yeah, I mean, if you guys want to joke around and have fun, James is involved in a lot of my stuff that I do, but I have a Facebook page called Electrical Wall of Shame, and we go on there and just post a bunch of crazy hack installs, or we post code compliant installs, try to get people to say it's a violation, stuff like that. But this Friday, I have to confess my sins to Electrical Jesus, and we have a Friday confession this week coming up. Mike Kozlov, shout out to you, brother. It's time. All you electricians out there, you must confess your electrical sins. I actually strapped a conduit at 14 feet the other day, so
right.
I went 4 foot over. I'm going to have to ask for forgiveness from Electrical Jesus and see if he could ever forgive me, and, see if that conduit's going to be all right with extra 4 foot of unsupportedness.
Let's see if he forgives you this week for tool of the week, since it ain't DeWalt.
Oh man, dude, I wanted to do a Milwaukee vacuum, but I think I already did the Milwaukee vacuum. That's the only Milwaukee product that sucks really good. But no, this week is actually the competition to mine, and I think you'd like it. I try to do a little bit of a comparison. One of the guys on the job site, we put our side by side, so I hope everyone likes the comparison of the Milwaukee versus DeWalt Sawzall this week.
All right.
It's Review of the Week. Sponsored by Electricians Only Tool Review and Nipex Tradesman.
Big shout out to Electricians Only Tool Review and Nipex Tradesman. Great groups. Check them out on Facebook and go join up. So this is the Milwaukee full-size version of what I showed. Was it last week that I showed it?
I don't remember.
The ranch. I showed the ranch. And like of course they don't put the Milwaukee battery on here because I made sure I put the whole battery and everything on the ranch. But I tell you what, like with my Sawzall, and if you sit there and try to hold it like upside down, up on a lip, 30 foot off the ground, your arm's gonna fall off. This Milwaukee's like a lot lighter. It has the 18 volt, and I believe they do have a 9 amp hour battery that is competitive to this. And it still does have the same optional slide out. And I think there's 3 selections on the slide out foot for your adjustment for wherever you're setting your blade depth at. Like I say, it was definitely a lot lighter than the DeWalt. The battery probably is comparable. I don't know for sure how long it really lasts. I did a full entire day and I barely drained 1 bar on mine, but we did quite a bit with the Milwaukee one, and I never really thought to check the battery, but it did good. It fared comparable. It had, I don't think, as much power. It seemed like it kept up, but it just seemed like it maybe was a little bit not. Like I say, the DeWalt Sawzall I would put up against any powered model. I mean, it just seemed like it was just unstoppable once you hit that trigger. The Milwaukee, what I noticed, which I thought was weird about this, was if you were like really digging into the blade and you're really cutting into your material, it seemed like it would just stop. And that was weird to me because my DeWalt doesn't do that. But it was almost like it kind of got overloaded, had kind of like a limit switch kind of. But overall, it still kept going. You know what I mean? Like it didn't stop all the way. It just stopped for a second, and then you had to kind of like back out of the groove and then dig back in again. But it was the first time I really noticed a flaw with the Milwaukee tool. Otherwise it performed, I would say, pretty close to identical with the DeWalt. It was just that weird stopping thing I didn't like. And it seemed to happen. Usually the Milwaukee seems to happen when the battery dies. So it could have been, I think the one that we were using was a 5 amp hour Milwaukee one. So it's really not a true comparison versus the DeWalt, because I had the beast, a brand new 9 amp hour battery from Baumgart's, $400, of course. But I mean, I was just tearing through with like that brand new battery and everything. So I don't know. This could have been like maybe even a defective Milwaukee battery that we were using. And maybe it was the battery that was causing the problem. But it just seemed weird when you started digging in real hard and finding on it that it would have this little stop thing. But otherwise, I think it kept up with the ranch, and like I say, it's a pretty good thing. So, like I say, if you like red and you want a industrial style Sawzall, that's one to go to. So,
all right. Well, you ready for your new thing this week, the Willie quiz?
Not yet, because I got to try to stump you first. Because I threw that little slide in there.
All right.
And this one's, I think we have some controversy on this one. We might have some people maybe mad. You might actually say maybe this question is wrong too. Maybe whoever wrote this question needed to go consult a certain Mr. Weedman first before he wrote it, and then make sure.
Okay. I see what the controversy. comes in it because you're asking for the supply side bonding jumper, and you're going to look over in table 250.102C1. And
Yes,
just
sir.
looking at the top of my head, a 2-aught, that should be B, a number 4. I think that's the right size. And
Ding, you nailed it.
yeah, and I'm assuming the controversy was that people were wanting to apply table 250.66, right?
Yeah, and I kind of try to I'm not really sure that I was clear on how that was really sized when I was, posting the question.
Mm-hmm.
And I think the reason I was confused was because 250.66 and 250.102C1 kind of have the same multiplier.
Mm-hmm.
So,
It's
we
the
kind of
exact same
figured that.
table. The only
Yeah,
difference is when you look at table 250.66, it deals with grounding electroconductors. When you get over table 250.102C1, that's where you're picking up bonding jumpers, supply side bonding jumpers, and things like that. But it's the same table, pretty much.
Right. And so for all you guys out there that were a little bit confused, because I might have added to that a little bit accidentally, just by trying to show that 250.66 was kind of the same multiplier in the same table kind of as 250.102C1. 250.102C1 would not typically give you a smaller conductor for bonding than the actual 250.66 of the surface entrance conductor. So you're not going to create that choke point. So that's kind of where I might have been confused a little bit in the initial when I posted the question, because I knew what the answer was, but I just didn't know if everything was copacetic. I knew the multipliers were right and everything like that. But I would challenge everyone who's in the chat, who's watching, to jump in. I'm going to try to stump James with a Willie quiz, and anyone is willing to jump in and put your answers in the chat, and we're going to make like a leaderboard and everything. I would expect that James will at least get one right, so you're automatically a shoe-in for the leaderboard. But if anyone wants to jump in and try to beat James and at least get more than one right, then we'll see. James doesn't really know the answers. I don't really. I kind of asked him a little bit if he'd like to do it, and so we kind of did this at Super Bowl. If you guys want to go check out the Super Bowl episode, I kind of did the same thing, stumped him on the Cowboys a little bit, but he always gets his second answers right. So as long as you guys get your first answer right, then you have a chance to beat James.
All right. I got you a video for the Willie quiz.
All right. Awesome. Well, good luck, sir, and may the Willie quiz be kind to you.
All right. Let's check it out. Let's see.
All right. What was the number one major concern for people having power in their house for the first time in 1897? This is when the first National Electric Code was published, and there was 4 major things that people were worried about, and this was actually done as like a survey at the time, I guess. But number A was cost, number B was lack of knowledge, number C was aesthetics, and number D was safety. Now, I would have never thought that people it doesn't, to me, if I have like a sweet EMT conduit run in my living room, I think it's fine. But I guess back in 1897, they were really bothered by it. But I don't know. So
that is pretty interesting. And being back then at that time, and electricity being new like that, people were probably scared of it. I would say they were probably scared, and safety would be the number one issue, and then probably lack of knowledge. Those are sort of the same, but I'll go with safety.
All right. Well, you actually get the first one correct, and D is the correct answer. So, boom, you scored 1 so far. So you won't get any more right the whole rest of the quiz, but you got your first one. So awesome, great job. Yeah, you did good. And no, the thing that was crazy was they actually showed the actual statistics on this, and safety was just barely ahead of lack of knowledge. So I was almost kind of rooting for lack of knowledge to beat safety,
Mm-hmm.
But when you look at it, that's really what we're battling against out here in the trade. Is we're battling against all these different forces, and the number one force is lack of knowledge. When you have that lack of knowledge, then you have a lack of safety, and then you have the other thing that drives the cost. So now all of a sudden you're cheap where you're trying to do an install for somebody at a cost-effective rate. It's costing you 3 times more because of lack of knowledge, lack of safety, and it's all kind of a trifecta. So
Right.
I thought that was interesting when I researched that.
Okay, let's see your next
one. All right, question 2. What individual had the most influence in the creation of the NEC processes? Thomas Edison, Elu Thompson, Nikola Tesla, George Steele, or William Stanley? And dude, if you're gonna go cheat with Pops right now, I'm gonna shut it down.
He's not here.
Okay, all right.
He's wanting to go eat afterwards, but he ain't listening. Okay, it definitely wasn't Edison or Tesla, and I don't think it was Stanley. So it's either I'm gonna go with Elu Thompson.
All right. So if there was like a second answer that you would have that you would want to choose besides Elu Thompson was a brilliant engineer, and he actually engineered a ton of stuff with AC current.
I knew that. That's why I went with it. I guess the second is William Stanley.
So if there was like a third answer that you could pick,
George Steele.
Yeah, you got it. So I did 2D in a row to try to throw you off.
I really thought it was Elu Thompson. That's who I would have when I looked at that.
And I thought so too, but they said basically out of all those names there, George Steele actually had the most amount of influence. They all did have a little bit of influence in the creation of the electrical code, but George Steele had the most influence from the way the format is, as far as it being like voted on and all the different members joining different code making panels and all that different. The way the format is today was because of George Steele. So I thought that was very interesting. And like I say, they all those names on the list did play a little bit of a crucial role in getting the National Electrical Code established. But George Steele was the one who kind of organized it, made it into committees, and probably put special experts on the board, which they don't do anymore.
Okay.
But I'm just kidding.
Yeah, they don't. All right.
So this one's a good one. Basically, everyone knows that the National Electric Code was driven by insurance companies. And so which insurance company had the most influence on the creation of the National Electrical Code process? So was it A, the New York Life Insurance Company? Was it B, the Hartford Insurance Company? C, the Northwestern Mutual Insurance Company? Or D, the Travelers Insurance Company? And I did research. These were all in existence in 1897.
I don't think it was D. I don't think Northwestern would be out towards there. I don't think they had anything. So it's A or B. I'll go with B, the Hartford.
All right. Well, I would have to tell you that you scored 2 correct answers. The answer is correct.
Yeah,
B
baby.
is the correct answer. So you nailed it. And like I say, 2 out of 3 is pretty good. And like I say, I tried to get a little bit of things that you might not know, but like I say, I was pretty sure that all you had to do is just look over at that 1897 code book you're going to send me, and probably says the Hartford right in front of it.
I don't know if it does. I did elimination. I knew it wasn't in the Northwest. I didn't think it was the Travelers because I don't ever remember anything they were doing with that. And so I was saying, I narrowed it down to A to B, and I thought, I don't think the code was done in New York. I think it was done in another part of the eastern state. So that's why I went with the Hartford. I did process of elimination.
I was trying to get you on that New York Life one because almost everything kind of comes through New York. But, like I say, it's funny because I see all of them and I'm like, oh, man, he's going to get that one. He's going to get this one. And it's really fun, but I stumped you at least once, so
I really thought that one was right. The one I missed, I thought, now I know that name. I've heard that name before because he did do it. And because I knew it wasn't Edison or Tesla. So there's only three left. And I was thinking, what? Now I know that one. And he did a lot of stuff back then. That Elu, I think that's the one it is. I was in my mind what I was thinking. I wasn't 100% sure.
Do you know what Elu is famous for?
What's that?
He's just famous for a lot of AC engineering. We covered motors tonight, and he's famous for a lot of AC motor designs. So I thought it was funny too to kind of tie into your motor thing that you covered. But I thought it was funny because I knew that you'd recognize some names and kind of, just be like jumping in on them, that was kind of what I was trying to get everyone on. But the thing that's amazing to me is how much, we've gone, like for one, the number one thing that amazes me is when you look at, there was 3 top things that were like neck and neck, and it was crazy. It was like 57% said safety, 56% said lack of knowledge, and it was, I don't want to give the exact percentages because it all adds up to 100, but it was like, I was just kind of trying to give an example, like 46% was safety, then like 43% was lack of knowledge, you know what I mean? And then you had like whatever percentage was left. And it was just crazy because they were all, when you looked at it, it was all neck and neck. They were all like 2% apart from each other. And I just couldn't believe that aesthetics was such a big percentage of people. Like they're like, I don't want Romex coming down my fireplace, and and of course, like we have this old cabin up in the mountains, and it's got Romex just exposed everywhere, and like nobody cares. It's just, oh yeah, it's a cabin, But like I could see where they don't want a bunch of big yellow Romexes just dorking down out of the ceiling everywhere, coming in to boxes everywhere. So we learned how to bend conduit and get decent at making it look nice and aesthetically pleasing. And I could imagine that some of those people that said they didn't like aesthetics would enjoy us bending some really nice slick conduit, making it look nice, hug tight, and basically making it to where you don't see the conduit. So that's improved, and there's a lot of things that's improved, but I really appreciate it, and I could like keep this quiz going.
I like it. 2 out of 3. That's pretty good.
Yeah.
I'm happy.
Dude, I stumped you finally on something. That's all I care. I got you on the Super Bowl one. That was fun.
I did. I did the process elimination, and I went with the name I knew of, and I was like, that's probably it. And but that's all right.
Well, my next one is going to be way easier because now I know how to at least get them on 2 out of 3. So now my next one's gonna be even easier. My next one's gonna be basically guessing.
That's okay. I like trying to get all those, that's actually fun because people get to actually learn something different about the code than just the normal, everyday stuff that you deal with. And, it's trivia. I like trivia. So
yeah, and I want to keep them going. So just hit me up on the chats and, hit me up in social media, whatever. I got the Willie Jackerson podcast page. I like how you threw Willie Jackerson's picture up in there. That's pretty funny. But yeah, it's a lot of fun to do these things. And like I say, it's always fun to stump James. James has done it to me enough that, now it's just like payback. And I'm trying to get him to finally square up on those, 12 code changes he still owes me for 2020, and try to, I'm just trying to even the score, man, I'm taking it out for the 1%, man. Like the 1%, like I've been getting dissed by the 1% too much, man. So
I love it. It's funny.
Take it back, man. But it's so much fun. It's so much fun doing these every week. And like I say, you provide such excellent content. And like I say, we're going to be getting it out there. James should have the states. He's doing the state of Colorado first. I would say right now, telling you, James, straight up, 98% of my following on Nat King Code page is state of Colorado. So
I'm
like
trying.
I say, they're all working on it. So
I was wanting to have everything done here quick, but it looks like it's going to take me another week and a half to finish all the pages and stuff. There's so much that's being done. It's incredible. I'd say by the time people go in and look at the website, the website's probably got 100 pages that have been completely being built out. They're almost finished now with the generator transform motor compressor for the 2023. That's the last part I have. And it's probably they got about another week on it. And then they'll take that information and build out the pages for the learning management system. And then once all that's done, it's just all we'll be doing from that point on is building courses. So, we spent the last 5 months, 6 months just building out all the systems and getting them ready. And it's going to be interesting because once we start the building process with the courses and stuff, you're going to see the 2020 start coming out. And all of a sudden you'll see calculation chapter. I mean, it'll be almost like a week to 2 week things. Here comes a chapter. Here comes a course, another course, another course, another course. Right. And by the time the end of the year gets here, I expect all 2020 that I wanted done completed. And that coming summer, all the 2023 will be done. And then we go into the design publication. And when I finish the design, you're probably going to be looking at between 20 and 23. You're probably going to be looking at over, not including state. But if I include the state, you're probably looking at an access to around 200 courses.
Nice.
So,
well, awesome, sir. Awesome show. I really appreciate everything. We're pushing like an hour and a half. We probably better jump off. I bet you Dad's probably gonna get ready to turn the lights out on you. And like I say, we're gonna get him back on that one. So
he likes to go eat on Thursday night. It was funny. Tuesday night, I was going up to Full House. Like, man, I need to eat before I go up there because I hadn't eaten all day, and I stopped at this place called Rose's, and I went in. I always get a lot of this. Usually same thing. I was just in the mood to get some tacos. I said, I'll have the crispy beef taco plate and just a water because I already bought a 44-ounce unsweet tea as in the car.
Mhm.
And he said $6.58. And I looked at him, I go, did you hear what I ordered? And he goes, yeah, you ordered a Chrissy V taco plate, didn't you? And I looked up at the thing, it's like 10 something. And I said, it says it's $10. He goes, it's Taco Tuesday. And I was like,
There you go.
you only charge $6. I said, heck, I'm gonna come up here every Tuesday for $6 because I love eating those tacos. But I was just shocked because I was like, that doesn't look right.
There you go. All right, brother. Well, we better jump off. Really appreciate everyone joining us tonight. Really awesome show. And, everyone, let us know in NEC for Dummies if there's anything you want to check out or see more of. And remember, make every day an easy day.
Right. Everybody have a good weekend. We'll see y'all next Thursday.
Deuces.